right, hello. So in this video, we're going to show off and demo using some tools that you'll be using to effectively test and grade your code. The two tools we're going to talk about are NPM, which is what we're going to use to install libraries and software for this class, and then Jest, which is the actual tool that we're going to be working with. So in order to grade your problem sets, in order to see, for example, if your code has worked the way you want correctly, we're going to be using a tool called Jest. Jest is what's called a test runner. It is a way of being able to basically run a bunch of code that tests the correctness or tests whether some other code works the way it's supposed to. So all the problem sets we provided have tests built in. They have checks to say, does the code do what we expect? Jest is the thing that will then be able to run that and see whether that works. So all those, if you look at any one of the, so if you look at any kinds of project, those tests are all defined in a file called spec.js, right? It's a specification, and the code itself is just JavaScript explaining what it's looking for. You don't need to worry about that. You don't even need to look at the file, but that's where that spec is defined. So what Jest is then going to do is we're going to use Jest to actually test and run this code. So Jest is a set of command line software, right? It's an application that works on the command line. It's not a program that you download. It's like an application like Word or Chrome or Visual Studio. It's a command line application. So in order to install that, we're going to use a program called NPM. So NPM is a package manager that comes with Node. It doesn't stand for Node Package Manager. That would make sense. It's just the package manager that happens to come with Node, and it's called NPM. You can really think of NPM as like the app store on the command line, right? It's going to let you be able to find and browse and install and manage applications and libraries and code bases and all these other things you want to work with. So it's used to do to install a bunch of different libraries. The two different ways that we're going to install things then is we can think about we can run this command from the command line by using the command npm, which once you've installed Node, you'll be able to have npm installed as well. They come together. You can use npm install to say you want to install a package, and then you put the name of the package or the name of the program you want to install. So if you want to install Jest, you would say npm install Jest. We're going to include the -g argument for any to install things globally across the entire computer, right? Not just in a single folder. And that's going to be used for things like programs, applications we want to run, like Jest. For libraries, think like dplyr style libraries, right? Things that are going to be used by other code that we write. We're going to install those locally, sort of in a particular project for a particular folder by not including that -g command. So if we want to install Jest, the way that we can start off by doing this, I have a slide on this. I do. The way we can start off by doing this is by installing Jest. So we'd use the command npm install -g Jest. Because I have Node installed on my computer already, I have npm. So I'm going to say I want to npm install the program Jest. And when I do that, it'll start going ahead and downloading and installing Jest and making this command available for us to use. npm install -g works great. That will install it locally. That'll install it locally on your computer. Sometimes, depending on how you have Node set up, you might have some problems installing those kinds of things altogether. Alternatively, what you can use is you can use another command that comes with npm called npx, which is npm's execute. And what that does, that downloads and runs the program kind of within its own little isolated environment. So rather than actually installing the files on your computer sort of like in a way that anyone can access them, it sort of downloads them, sandboxes them, and then runs them individually. So using npx to run commands like Jest can often work slightly better, depending on how you've set things up. I personally like installing Jest globally because that way it just runs a little faster. I'm going to wait for it to download and sort of reinitialize every time I run. Cool. So as you can see, it takes a couple minutes for Jest to install. Whenever you install packages, you may get warnings. Warnings you can generally ignore. You might even get some like critical warnings about like version dependency stuff. That's okay. Whatever you do, if you get a command that says something to run npm audit, don't do that for this course. Like there's nothing dangerous that's happening with anything we do. Don't try to like fix installation issues because they're going to cause issues. It will cause other problems further down the line. If you have any problems ever installing things like Jest, reach out to us, let us know so that we can be able to help and support you getting the software you need installed. All right, once we have Jest, then we can use that command to test our code by running the command Jest and then whatever thing we want to test. So in order to run Jest on a problem set we need to be inside that folder. We need to be inside that package. So for example, if I want to test out my my basics demo here, which is just some like basic, like some blah HTML, I need to make sure I'm inside of this folder, right? Inside this basics folder. So that thing is on my desktop. So I'm going to change directory into my desktop. I'm then going to change into this lecture demos folder. And then I'm going to change into this basics folder, because that's, again, where this file is, right? If I look to see, that's where my spec file is that I want to run. Technically, I can be in one command up from this and it'll still work okay, but it's best to really kind of be inside the folder we're interested in. So for your problem sets, you want to be inside of the problem set folder, right? Problem 01, your name. That's where you want to be able to do test these things, make sure your code works. All right, from there, we can use the command Jest. Because we've installed Jest as an application, we can now use that command. We can say run the Jest program. So how we would say run the Git program, we can say run the Jest program from our command line. And the argument it'll take is then which spec file or which folder do we want to test. So in this case, I can say I want to test the basics folder, test the content in my basics folder. So I can just say run Jest basics. I can also say run Jest demo. I can also just say run Jest, and then it'll test anything it can find, which will also work just as well. But I'm going to go ahead and say run Jest basics because I want to test one thing at a time. I often find that's a little bit easier to make sure that I don't get overwhelmed if there's lots of different problems or lots of different specs in the same folder. All right, so if I run Jest basics, everything takes a minute, so that's okay. We're just going to be patient. As you say, it says it's running demo.spec file. It found the right thing. And I get a big red fail, which is okay. Don't panic. And then some details. So notice that what it says is that whenever you get output from a command line, you always have to sit down and read that output and see what was it that I got. So from here, you can see it said that the test suite failed to run. So it's not that I failed my test. It's not that my code didn't work. It's that I failed to even do the tests in the first place, right? The suite failed to run at all. And then it tells us why. It says it cannot find a module called Jest style matchers from demospec.js. And then it has a stack trace to tell us sort of where that code was required that it was found. Okay. This error cannot find module means that I haven't installed the dependent libraries that the spec file needs to do its testing. Think of it a little bit like how if you want to run some code in R, you probably need to have dplyr installed, because that way your code like uses dplyr methods and needs to go like make those code do that thing. Effectively, we need to make sure we've installed those dependent libraries. So we could install this manually. We could write npm install and install all these pieces, but there might be a whole installing this individual library, but there might actually be a whole lot of libraries that we want to install, a whole lot of dependencies that we need, right? I might need dplyr and ggplot and stringer and all these other, I mean, those are all R libraries we're doing JavaScript, but we might need a whole bunch of these pieces. Luckily, when using npm, all of those dependencies can get listed in a file called the package.json file. The package.json file has all the information about the sort of that repository, that project that the node needs to understand. So in particular, you'll notice that inside this file, this is a JSON file, basically a bunch of configuration information. It includes inside of it a list of dependencies. These are marked as dev dependencies. You'll also see one that's just dependencies. They mean the same thing. Don't worry about them. Don't worry about the distinction at the moment. And it'll list all the different libraries I need to install, and then what versions of those libraries in particular I need to install, right? So maybe I don't need the newest version. Maybe I need one that works at a certain pace. It worked at a certain time, a certain snapshot. The package.lock file also then has snapshots of all the other libraries that might be needed by those libraries, right? It's possible that installing Jest style matchers also requires a bunch of other things along the way, and I have to install all of them. So in order to install all these different libraries, right, in order to install these dependencies, we can use another command from npm called npm install without any other arguments. We're just going to say npm install. And when we do that from within a particular folder, like our basics folder, it will go look at the npm will look at this package.json file. It'll look at all the listed dependencies that are in this file, and it'll just install them all. It basically just goes through the shopping list and installs everything that's in the list without us having to write them out individually. So effectively, I can just say npm install, nothing else, and that will install all the dependencies all at once and installs them locally for this project, so for this problem set. So if I run npm install, start spinning, and then it goes ahead and installs a whole bunch of things. Again, here's one of these things yes, I understand that like sometimes it'll report things like vulnerabilities. We're not doing anything dangerous in this class. Like nothing in this code is becoming public. It's all practiced locally. There's nothing that it can possibly do to harm you. Don't worry about it. Whatever you do, please do not follow this instruction. Do not run npm audit fix. You'll change the dependent versions of your code in ways that'll make all your tests fail and nothing will work anymore. Do not do that, please. Cool. But again, we run npm install, we look and it says that everything installed successfully, right? We don't see any errors or warnings we can deal with. We don't see any errors. So we're looking to see that's installed. And that means now all these packages, the dependencies are available. Where they get installed is in, and I can actually, if I would have find it, I can show it to you there, might be a little bit easier. Inside this basics folder, they get installed into this folder called node modules. Node modules is the folder it's like the program files folder. It's the folder that contains all of the installed dependencies for that project. Every project will have its own node modules folder. None of these dependencies are installed globally. They're always per project because every project might want a slightly different version of different files. Right? Inside node modules, there's a whole bunch of pieces that got installed. Right, there's all the stuff that got used by JavaScript because JavaScript uses a lot of pieces, including somewhere in the middle. Wait for it. Is the Jest style mattress thing it was looking for. So that does get installed. So all those files, all those libraries, all that code is inside this node modules folder. What that means, if anything ever gets corrupted or doesn't work correctly, what we'll often tell you to do is to delete this folder, right? You just delete it and then reinstall the dependencies, and that often will kind of clean it up and try it again effectively. Okay, so once all of our dependencies are installed, then I can go ahead and run Jest again. So I can then run my Jest basics one more time. And we're patient, always patient. Cool. At which point, now notice it doesn't say that the test failed to run. It says that the test did run successfully, but there was still a failure because something went wrong. So what Jest will do is that its output, it'll run through all its tests, and at the top it will give it. There's sort of three parts to its output. The first part is the summary. That's what this is. This is the summary list of all the things that it kind of checked, that it looked at, and whether those things worked or didn't work. So it says that it checked that the HTML validates without errors. That did not work. It checked that the CSS validates without errors. That did work. CSS. And checked that my JavaScript linted without errors. And that did work. We got a green check mark. Right? Check marks mean great. It worked. Everything's fine. X means no, it did not work. That's a summary. And there's only three things I'm checking in this quick demo. In your problem sets, there'll often be 10 or 15 or 20 or 25 things that you're checking, right? And you'll get this long list, this long summary. The summary is just that. It's a summary. It's like a table of contents. It says, here's all the things that may have happened, gone wrong, but that doesn't tell you what the problem was. It just tells you that, hey, I looked at this thing and it didn't work. And saying I did this thing and it doesn't work, you can't do anything with that. So if we want to know, well, why did it fail? What went wrong? We have to go down to the next part. The next part is going to be a listing of everything that failed one at a time and telling you what about it, what assertion, what did it try to check, and what then did not work correctly. So in this case, for example, it tried to check the HTML validates without errors, and in the process, it got an error. And now, right, see how we're reading our output. My error says that I had a tag close error at line 8 of my code in column number 5. So if I go to my code and I look at line 8, right, here's my line 8, I can stare at this for a moment and I say, well, there's a tag closing error. Let me look at my closing tags. Well, I've got a closing, I do have a closing tag in H2. Oh, wait, my opening tag was in H1. Those two things have to match. So what I can then do is I can then fix my code, right? I change it. I'm going to save my changes. So now I've fixed my tag. So now it's accurate, right? The tags match. And I can go back and rerun Jest, right? I'm going to run my command again, run my Jest basics. And at that point, it says now I pass. All my different checks were green lit. They were all successful. It tells me there were 3 things it checked, and all 3 of them succeeded. 3 test works. Everything is great. To be clear, let me see. Quick. if I go into, for example, if you look at what problem one looks like, install its dependencies real fast because they're already there. Great. So if you run Jest on things like your problem sets, and this is again a problem set that hasn't been completed yet, right? Nothing has started on this thing yet. Again, it takes a moment. That's okay. Don't panic if it takes a few minutes. I'm not panicking. Again, a lot of things fail. And here, so there's a really long summary list of which everything has failed because I haven't done any work yet. It's an incomplete problem set. So clearly everything falls apart. Yeah, my HTML is good because I haven't written it yet. So again, you can't just look at the summary and be like, well, like, what's wrong with it? Why is this failing? Because the answer is, I don't know. You have to look at the details. And the details would say, why does that line fail? And you can then look at those individual pieces, right? My CSS validates without errors had a problem because there was an unexpected empty source. My file was empty. The other things you want to then do is, that'll help some of the validation works. As you get to some other parts of code, as you scroll down and look at this output, you'll be able to see some things where, for example, this thing it's saying that my HTML specifies a character set. What you can do is if you look at the stack trace, you can figure out what is the code that is being used to test that it's actually looking for. What is the assertion? What is it trying to see is actually true? It's all in JavaScript code, so you might not be able to read it, and that's okay. Sometimes you can kind of make it out if you kind of ignore punctuation. But there is generally a comment, like a Java style comment, which is a little bit gray, might be hard to see, that tells you what it's looking for. And I'm saying I'm expecting there to be one tag. That's what I'm checking. I expected there to be one tag. I found 0 tags. So the expected says what I was looking for, and received says what it found instead. And if those two things don't match, there's a problem. So if you want to know why does something not work, what you'll need to do is you'll need to scroll down past the summary into the details, look to see what it was trying to assert, look for that comment that explains what's going on, see if the expected value is different from the received value, and that can help you figure out where that problem might be. Best practice is to start fixing things from the top. Don't scroll down to the bottom. Don't try to find the easy test fixes and fix the things in the bottom. Start from the top. Jest tests are run in sequence, so it's often, particularly in later problem sets, it's often possible if something doesn't, if an early test fails, that'll cause later ones to fail as well. But if you fix the early one, suddenly everything begins passing because suddenly now it knows where everything is and everything works fine. So again, that's how you can do to be able to check to make sure all those pieces work. And again, once you fix all the problems, you'll eventually get to the point where you've all got green passes, which means your problem set works, everything's perfect, you've written your code as well as can be expected, as well as we can test for. Okay, cool. This is really, really, really important. Jest is a program that's used for grading. It's used to see if your code is correct. It's not used for debugging. It can't tell you if your code works. It tells you if the code was correct according to the test, which doesn't tell you if it does what it's supposed to do. Sometimes those things match, and Jest can be good about those things, but not always. The way to debug your code, the way to see, like, did it do what I want? Is it working correctly? Is to test your code in the browser. Open up your web page, open up your problem set, and look at the code that you wrote and its effect and how it gets rendered inside the browser. Don't do that using Jest. Jest is not a debugging tool. You don't run Jest to see whether there are bugs, and you don't use Jest to find bugs. You use the browser to see if there are bugs and use the browser to find and fix those bugs. Jest is only used for grading. The correct way to think about this is to go through your problem set, write all your code, do the whole problem set, checking your work in the browser as you go. Once it looks perfect in the browser, it works perfectly there, once you're pretty sure you're done and everything seems great, then you run Jest as a final check. And then Jest might say, oh, you missed a step here, in which case then you go back and you run it, and you test it, and you work through in the browser. Jest might say that you got a typo. Jest might say, oh, there's something else that doesn't actually work the way you thought, in which case you go back and you check your edge cases in the browser again. Do not use Jest for debugging. Use Jest at the end after you've done all of your coding and you've done all your checking and your debugging in the browser. Use Jest only for grading things at the very end. Great. At the very end, once you've run your Jest test and you're sure that everything has worked and there's no typos and everything's been fixed and you got your green passes, then what you're going to need to do is you're going to need to upload this code to GitHub. Right? You're going to need to push your code to GitHub to commit your work and say that I'm done. Right? That's how you share it with the rest of us so we can grade it. what will happen is that we've set up these problem set repositories so that when you push your code to GitHub, GitHub will actually run Jest on your entire repository. It'll go run Jest and see whether all your code passes or not. And if all your code passes, right, if you're able to get your green pass mark when it runs Jest, it'll show a little green check mark next to that commit. If when it run Jest on the problem set and it didn't pass, right, maybe because you hadn't finished a problem yet, for example, you're going to see a red X. If you get to that green check mark on GitHub, that means that you've turned in code that passes all the tests and you get full credit on your problem sets and life is good. Importantly, GitHub runs Jest on the entire repository, on the entire problem set at once. It doesn't run on individual problems or individual folders. So what will happen is you need to look at the commit. Does the latest commit have everything working? If you look at a commit and you get a red X, that doesn't mean that there was a problem with like problem A. It doesn't mean you didn't have an issue with problem A. It just means that the entire problem set, problems A, B, C, and D, were not all together, all combined, working perfectly. So what you need to do is you want to, again, make sure that the whole thing is finished, and that's when you want to be looking for your green check mark. If you don't, you can click on that green check mark in order to be able to view the details. You can actually see what GitHub is running, how Jest works, what its terminal output is. I don't have a demo of that because I don't have it set up to run GitHub at the moment. But you can do that to be able to see what those details are. In general, if it runs perfectly on your computer and uploads to GitHub, it'll work fine on GitHub as well. Great. So again, that's how we run. And so those are the two things we need to know, right? We run npm. We can use npm to install applications, right? npm install, let's install Jest. npm install to install those dependencies, which we need to run our problem sets. And then we use Jest to actually run that command, look at that stuff on the command line. There's more details about npm in the textbook. Jest is not in the textbook as well as much, but this is basically how it works. And as always, if there's any questions, please let us know so we can be able to help you out.